Okay. Thanks so much for creating time for my session. My presentation is going to be in three folds. I would like to discuss about wastewater as it relates to textile industry. Then we talk about synthesis and characterization of adsorbents for the removal of dyes from aqueous solution. As we know, the textile industries constitutes the major source of water pollution due to the anthropogenic activities, due to the consumption of water and pollution as a result of the consumption. The increase in textile products, we all know, is proportional to the increase in the amount of synthetic dyes that is being utilized. According to United States Environmental Protection Agency, it is well known that wastewater generated from textile industry can be classified into 4 categories: high strength, dispersible, hazardous, and hard to treat. It is estimated that 36,000 of water is consumed by fabrics production. This is because textile industry consume a lot of substantial amount of water, and as a result of that, pollutes the receiving water and the environment. An example of such pollution can be seen in a river in China as a result of discharge of dyes. The discharge of dye wastewater can affect the aesthetic nature of the receiving water due to the complex molecular structure of dyes. As a result of the complexity of the molecular structure, there is bioaccumulation in the food chain. And as a result of this, we have cases of toxicity, we have mutagenicity, we have carcinogenicity. This is because when dyes is being broken down under anaerobic conditions, it is being converted into carcinogenic aromatic compounds. And as a result, it is stated that 80% of waste from textile industry constitute untreated effluent into the receiving water. So the synthetic dyes, as it were, as relates to the environment, constitute both environment and public health situation. Example of such is rhodamine B, which is carcinogenic. Dispersed dyes are intended for polyester, acetate, and hydrophobic fillers. It is estimated that 85% of dispersible dyes are azoles and anthracyclines. This is due to their low solubility in the water. Because they are low soluble, in terms of solubility, they are not soluble in the polar phase. This is due to their hydrophobic nature, as the particles are non-polar, so the tendency for there to be interaction with particles of their kinds rather than with water. Because of this trend, hydrophobic particles suspended in water has the physical nature of voids in bulk solution. The consequence of such behavior results in the expansion by the breaking down of hydrogen bonds between water particles. The effect of the breaking down of the hydrogen bonding as a result of expansion brings together the hydrophobic particles immersed in water. This can be achieved in 2 ways. When two hydrophobic particles immersed in water and cluster, the surface area of the particles is smaller than the sum of the surfaces of the combining particles. As you can see from this figure, we have hydrophobic particles. The non-polar phase tends to cluster by the breaking of the hydrogen bond. In the process, excludes water. So in this case, It is always attached to a surface that has the propensity for the adsorption of the non-polar solutes, and that is always achieved on an hydrophobic surface. As a result of this, the energy leading to the breaking down of water particles proportional to the surface decreases as a result of the qualities of the particles. This makes the process leading to the qualities thermodynamically spontaneous. The interaction of the molecule is achieved at high state of entropy. This is the reason causing the nonpolar molecules, such as dyes, to clump together in aqueous solution. It is known that when two hydrophobic particles move together and combine, the free energy of the system favors adsorption on the particular surface, or adsorption of the particle to the surface. The more the surface are hydrophobic, the more strongly the tendency for them to cluster together. And this leads to the synthesis of hydrophobic bone surface. We have worked on hydrophobic bone surface from cow bones, but the composition, as you can see, bone charcoal has a composition of both carbon and minerals in the form of calcium carbonate, hydrated phosphate, and hydroxyapatite. And insoluble calcium phosphate, when used as an interface between the adsorbent and the adsorbent, is formed. So in a nutshell, an insoluble precipitate is always formed, which serves as an interface between the adsorbate and the adsorbent. When calcium oxide dissolves in the water, it forms calcium carbonate, which has tendency of forming an alkaline precipitate. So adsorbent enriched calcium activated cow bone powder is known to contain calcium oxide, which, excuse me, experimental analysis of the preparation of activated cow bone powder, that's the experimental part of the synthesis of the hydrophobic adsorbent. Cow bones experiment was conducted on a laboratory scale. That's by the synthesis of cow bones as an adsorbent, which was obtained at a local retail store in somewhere in Malaysia. The raw material was subjected to physical activation at elevated temperature of 700 degrees Celsius. Bone, according to Chechinel and De Souza 2014, claimed that bone becomes activated at a temperature in the range of 500 and 850 degrees Celsius. The process of activation began with washing of the bones. Just a minute. With the seawater to remove the surface impurities. The bones were later oven dried at 105 degrees Celsius for 24 hours. The dried bones were crushed using mechanical crusher, leading to the next stage, which is pyrolysis of the bones, which was obtained at 700 degrees Celsius for 5 hours. That's the ignition temperature. So that leads to the formation of chars. The chars that were formed were in different particle sizes, which was achieved by the use of roller grinder. So we had different particle sizes of 75 micrometer, 150 micrometer, 250 micrometer, and 300 micrometer. And the procedure for the preparation is illustrated in the figure 4. This is the bones starting from the washing, the drying at 105 degrees Celsius. Then this goes with the crushing, the mechanical crusher. Then this is the activation stage where the bones were activated at 700 degrees Celsius for 5 hours. So at the end of it, there were reduction in particle sizes from 75 to up to 300 micrometer upward. And this is the cow bone powder produced as a result of the synthesis. Then we carried out characterization study to determine the hydrophobicity of the adsorbent. And from the characterization study using the contact angle experiments conducted using water drop penetration test, it was observed that the interaction between the water molecule and the surface of the synthesized carbon was at 95.5 degrees Celsius, and this is another contact angle experiment. We could not put all the characterization studies for the sake of this presentation due to time and due to the nature of the whole characterization study, because we carried out SRD, SRF, EDX, and all that, FTIR. The contact angle, when we use contact angle, we use contact angle basically to determine the wettability of the adsorbent, which is influenced by the cohesive forces of liquid molecules and the interaction between the liquid and the surface. Hydrophobic characteristics of adsorbent creates active sites for the absorption of non-polar solutes by the reduction of contact with the polar phase. That is, when they cluster, they tend to be attached to the surface of an adsorbent that has propensity for the attachment on an hydrophobic surface. That is done by the exclusion of the polar phase. This is achieved at high state of entropy, usually by the breaking down of water molecules, which in turn leads to the clumping together of the non-polar solutes. These are some of the characterization studies from the morphology that was carried out from the morphology characteristics of the adsorbent. As you can see, the microstructure and the surface of the activated carbon adsorbent was investigated using scanning electron microscopy. And this is the surface characteristics of the adsorbent, which was observed at 10,000 magnification. The morphology of the activated carbon powder showed a fine, evenly distributed and well-aligned particle sizes with close aligned pores, which creates active sites for the attachment of for the attachment of the adsorbent on the surface of the adsorbent. This first experiment was carried out using palm oil meal effluent, which is a known effluent in Malaysia as a very high strength industrial wastewater due to the concentration of the physiochemical parameters. It is known that the discharge of palm oil meal of effluent without adequate treatment, effective treatment, tends to lower the dissolved oxygen available for aquatic respiration, both in the receiving water and on the environment. The consequence of that raises the chemical oxygen demand, the biological oxygen demand, due to the reduction in the oxygen available for aquatic population. From the chemical characterization, this is one of the characterization study using energy dispersive Xray test from EDX spectrometer. As you can see, we have the calcium, and we have the carbon, the oxygen, and calcium as the major elements that is composed in the carbon, activated carbon powder. We have carbon 26.60%. We have oxygen at 7.06%, and calcium was obtained at 23.30%. So from literature, carbon, oxygen, and calcium are the known elements that is composed in carbon powder. So when they react in aqueous phase, they tend to form insoluble precipitate, which tend to serve as interface between the adsorbate and the adsorbent. So this is the EDX we have the FTR, but that wasn't included into the slide presentation. And others observed that the synthesized activated carbon powder contain high element of carbon, oxygen, and calcium, creating an insoluble precipitate, which serves as an interface between the adsorbent and the adsorbent. The adsorbent achieved higher removal capacity of high-strength organic pollutants. The COD was effectively reduced, and some heavy metals present in the palm oil mill effluent. These are some of the results that was obtained and that was published to that effect: optimization of operating parameters of novel composite. From the activated carbon powder that was formed, we later carried out we later synthesized a novel composite, that is the combination of activated carbon powder, zeolite, because of the hydrophilic properties of zeolite, then the activated coconut shell powder, which is believed to have, which is known to have high surface area to effectively reduce uh, the pollutants or organic pollutants from pole to zero discharge, to discharge level. So these are some of the publications that is related to the present work. So we are carrying out an optimization study for the adsorption of rhodamine B. This is another publication. We carried out a statistical test after the adsorption experiment using rhodamine B dye from aqueous solution. In the second phase, we intend to carry out preparation of nano-ion bone composite. That's by the preparation using in situ synthesis method to explore an efficient removal technology for dyes in aqueous solution. The bones will be washed based on the previous literature, will be washed then dried at 105 degrees Celsius for 24 hours, which will be followed by crushing, after which there will be washing and oven drying for 24 hours to reduce inner moisture content. The dried bones will be sintered at 700 degrees Celsius for 5 hours. The process will be followed by crushing, after which powder samples will be reduced to 75 down to 300 micrometer, and the synthesis of the nano-ion bone composite will be achieved by adding 0.5 gram of different particle sizes, respectively, to 9 ml of 0.445 mole per liter iron, and stirred vigorously for 15 minutes at 15 degrees Celsius under nitrogen protection, which will be followed by 10 ml of sodium borohydrate, which will be added dropwise with a continuous stirring process, after which vacuum drying. So we intend to carry out characterization studies using the FTIR, the EDS, BET to determine the nature of the particle sizes, the SEM for the morphology, for the chemical composition, surface area and porosity, and the morphology of the sample before the adsorption studies will be examined. So this is my presentation.